Great. Welcome to the AI conference. This is going to be a very speedy advanced RAG panel, so let's get to it. My name is Christy Bergman. I'm your moderator today. I'm an AI developer advocate, previously at Zilla's, the vector database, and previously before that at Anyscale, and before that at AWS. So that's me, moderator. Over to you.
Oh yeah, Marwan. I'm an AI engineer at Anyscale.
Hi, I'm Prashanth, AI engineer at Kuzu, a graph database company.
Hi, and I'm Ofer. I run developer relations for Vectara. We do RAG in a box, RAG as a service. Yeah.
All right, so this panel is about advanced techniques in RAG, and just in case you have not heard, RAG stands for Retrieval Augmented Generation. We have a nice slide prepared by Ofer here. So you start out with the user's data. It could be structured enterprise data, or it could be unstructured, such as images or video or text. Then you have the data pre-processing, where if it's images, you have the image transforms, turn them into squares, for example, downsize. Text chunking for text, multimodal, maybe you need to take care of schema. For the embedding model, the bi-encoder LLM, you need to choose one, and then use it to encode your unstructured data into vectors. Then you also need to keep that exact same embedding model so that you're encoding into the same vector space the user's question. Then you have a retrieval step where you find semantically similar knowledge from your encoded data to the encoded question to answer the initial question. There's a rebanking step, possibly, in order to reorder the outputs from the retrieval. And then there's a prompt where the generative, now we've got a different model here, the generative decoder model, the LLM, needs to be mindful of the prompt and the parameters of your LLM model to formulate the query, the instructions, the context, and the output, and making sure all of that stuff fits within the context window. And then post-processing might be where you take it out and pass it through guardrails, safety, formatting. You've got your query and your response, maybe log that. Good place to send this into memory system or an agent system, and keep on improving. So that's a quick introduction to RAG, very fast. Thanks. So our first question for the panelists is RAG dead due to long context lengths of LLMs? We've heard about the paper Lost in the Middle from the UC Berkeley 2023, where accuracy actually goes down with the number of contexts that are stuffed into the prompt. We've heard of the needle and haystack studies by Greg Cameron and Lance Martin from LangChain. And then also, I just mentioned, what is a context length? It's the total number of tokens input plus output that model is designed to handle. For example, GPT-4o, it's 128,000 with 496 output tokens, and Llama 3.1 8B is also 128,000 tokens. Prashanth.
Yeah, so my take is that RAG is definitely here to stay. From a retrieval and question answering standpoint, you can think of extractive style questions where you want to retrieve a specific response from a localized portion of the data. And then an abstractive style question answering where you have synthesizing and summarization of answers from multiple sources in the data. So in both cases, I think there are different benefits to RAG versus long context LLMs. And I think the real standout for RAG in extractive question answering is the cost and latency factor, which is hard to beat when you're comparing it with a long context LLM with context stuffing. So I'm sure the others in the panel have a lot of thoughts on the trade-offs between cost and latency, so I'll let the others talk as well.
Okay, Ofer?
Yeah, so I think I agree with you. I think when long context started happening, we had 128,000 and 1 million, and now we have, I think somebody announced just 10 million. People said, okay, so we can stuff everything. But like you said, the latency is really large. Like Christy said, you may not find what you want. It's not guaranteed to work as well. But one thing I want to add to that is actually long context helps RAG be better. And that's the promising part of this, because when RAG started, everything was like 4,000 tokens or something. So you had to really be carefully choosing which facts, which chunks you're going to put into the LLM and make sure that it works properly. And you sometimes had to make some trade-offs and give some up. And now, longer context, you can much more easily include more context, give the LLM more stuff to work on. And that's really exciting. Opens up a whole other set of options.
Yeah, I take a little bit of a different side on this, is that like with long context, maybe you have to like think clearly whether you need drag or not, because especially if you have control over your own like language model inference engine, then you can start like caching this long context and amortizing that cost over more than one request. And so yeah, like don't go to like building a complex system like RAG if you don't need to. Yeah.
Okay. So another question, how do you evaluate RAG systems, given there are many moving parts and components to a RAG system, and the knowledge is always changing? Prashanth, I'll go to you first.
Oh, sure, yeah. So I think from an evaluation perspective, it's important to evaluate the retrieval side and the generation side separately. And there are many metrics on either side of those. Some of them I'll mention briefly: context precision and context recall. These are on the retrieval side of things. And the way it's done is typically through an LLM, where you actually find the signal-to-noise ratio in the retrieved contexts, and also whether the retrieved context contains answers or relevant information for the answer. On the generation side, you have metrics like faithfulness and answer relevance. Faithfulness is a way to measure the factual accuracy of the response, and answer relevance is, of course, how relevant the answer is to the question. So the key point I'm trying to make is that it's important to devise an evaluation strategy for RAG by starting with a baseline. And typical baseline would be something like a keyword-based search, something like a BM25 search, and then you progressively build on top of that. You add vector-only RAG, you add advanced methods of RAG, like agentic RAG or graph RAG, and as each step progresses, you kind of come up with an understanding of whether the evaluation is helping you improve your system.
Okay, I'll just say a quick word about LLM as a judge is a technique. Before LLM as a judge paper came out, people thought that they needed thousands of data points to evaluate Gen AI systems accurately, and then it was proven that with the idea that humans are basically Bayesian limits themselves. We aren't always agreeing with each other. In fact, we only agree with each other about 70% of the time. And if you took a GPT-4o model, it was agreeing with humans at the same amount of time as a human would agree with a human. And therefore, LLM as a judge came about. Some known weaknesses, like if you ask the LLM as a judge to rank with whole numbers, that's bad, because LLMs tend to choose boundary numbers like 0 or the highest number, and humans tend to choose midpoint numbers. Don't ask a LLM as a judge if it's complete. Also watch out for the critic model that's used. GPT-4o does start working, but before that apparently there was some randomness. And I'll move off to Ofer.
If I can just add one more thing to that, is like I think you totally agree with the metrics. I think that's a good, thank you, a good rundown of the good metrics. One thing that's interesting about LLM as a judge is that it's actually quite slow. I mean, you know, LLMs take, I don't know, 2-3 seconds to get a result, and expensive. So when you run a big evaluation test, it could cost you quite a bit, especially if you want to run different scenarios and things like this. And I'm saying because one of the things that we recently open sourced at Vectara is called HHEM. It's a hallucination detection model, which addresses part of LLM as judge, especially the retrieval part or the generative part, like do you use the right context? Is the context represented well in the generative summary? And HHEM is a traditional machine learning model. It's a classification model. It's very fast, and it's not only cheaper and faster, but also more reliable. So what we found in our testing is sometimes you run the LLM as a judge today, and you run it tomorrow, and the model's changed a little bit, so it gives you different results. So it's a little bit robust. So use LLM as a judge a little bit at your own risk, and be aware of the fact that it kind of changes sometimes in its outputs.
All right, and yeah, there's more to be said about evaluation data sets as well, and ground truth answers. But moving on to our main question today, is which hybrid RAG techniques are you the most excited about, and why? I guess I'll mention hybrid RAG, which includes multimodal data, which could be text or images. And this is useful for recommender systems, for example, where you have many different texts, maybe images, videos, representing the same object, an item. Also chatbots, which you might want to bring in sources of data from PowerPoint slides and videos and different company assets. In both cases, you would need the re-ranker. With the multimodal models, a linear reciprocal rank fusion works, but for the other things, you would need an actual other LLM as the re-ranker, such as the Colbert V2 late interactions. I will pass it on to Ofer.
Yeah, so absolutely excited about those things. I would add to that, one of the things I've been working on recently, which I think is really exciting, is agentic RAG. If you haven't heard about this, agentic RAG is this ability to take the kind of, I'll call it vanilla RAG, for lack of a better word here, and add to that automated agentic capability. So this will be the ability to look at the query and sometimes break it down into multiple RAG queries, understand the context. And agentic RAG uses tools. So you can give it tools to ask queries and get the response, but also integrate calls to REST APIs and things like this that give you real-time information. Take all of that context, both the kind of the retrieved context as well as the real-time context, fit it into the LLM, and get the LLM to give you a much more contextual response. So it's really important for enterprise deployments, for example, where you want to call, let's say, a database call and get some other information when you build your RAG system. So really excited about agentic RAG. A plug for me, we just launched something called Vectara Agentic, which allows you to use agentic RAG with Vectara. But if you're interested, you can find it in our booth later on. But pass it over to Prashanth.
Oh yeah, sure. So I think one thing to clarify regarding hybrid RAG is that it's essentially an extension to vector RAG, because when RAG first came out, it was vector only for obvious reasons. And recently, there's been a lot of buzz around the term graph RAG, so I'm really, really excited about this, working at a graph database company as well. And I'll briefly touch upon why I think it's exciting, because what graphs provide is they explicitly model the entities and relationships in the data. And what's been happening in the last several months is there's been more and more work coming out that document the benefits of having a graph alongside a vector database. And the combination of these two essentially allows you to retrieve different parts of the context and combine these contexts in a way that you can actually pass that to the generation model for better response. Now, it's not guaranteed that graph RAG is always better than vector RAG, which is why the evaluation methodologies that we mentioned before are really important. But in a nutshell, the idea of explicit relationships being captured in this workflow, I think, are what's most exciting. And as these systems get more mature, I think agentic systems are also going to come into this world as well. Mm-hmm. So you might have agents that are calling tools on one hand, vector databases on the other hand, and graph databases. And all of these work in harmony to provide the LLM with the required context.
Great, thanks. So lots of exciting things, and we're not able to talk about all of the things we really want to talk about, so feel free to hit us up on the app, and we're happy to send out more links. Okay, so the last question of our panel today is, what's the biggest challenges of implementing RAG? And I'll go to Ofer first.
Yeah, so lots of challenges, but I'll mention three that are top of mind for me. One is trust and privacy, and I think most people I talk to in the community are talking about this. Like, how do I build a RAG system that does not, say, call some vendor outside and my data leaks and gets fine-tuned on or something like this? So I think security and privacy of data is one of the big concerns I hear a lot about. The second one is people talk about RAG and focus on the LLM. Are you using this LLM or this LLM? But the R in RAG is actually really important. It stands for retrieval. RAG essentially is a search-based system. You search your massive data of chunked data, however you do it, and you have to essentially be able to build a retrieval system that picks up the most relevant chunks of data to feed into the LLM. And again, we talked earlier about longer context. If the context is longer, you can do more, but you always have to pick some number of chunks that are relevant, and the retrieval becomes really important. So most people focus on, let's say, the vector search, the neural search part, but there's also hybrid search, which combines neural search and keyword search. There's things like re-rankers. There's a lot of different techniques that you can do to help make the retrieval part better. So I would encourage people to think about that, because when you scale, that becomes a much more difficult problem, is to get those right things. The third thing is, and it's something that we work closely with our customers. A lot of people are starting to think about this build versus buy, right? So I build a POC about RAG, I pick up the components, I do the 5 things I need to do on a small data set, and it seems to work great. And in 2023, it was like, oh, I'm a hero. One page of code, and I can build a RAG system. But when you scale this up in an enterprise context, it becomes much more difficult than you might imagine, and maybe you do imagine. It's difficult to maintain, it's difficult to update. When you scale, other systems come up, and this is not new. With enterprise deployments of other systems like databases and others, we've seen this before. So tech is just not easy that way. So a lot of people are starting to think about, okay, maybe we need to not build a stack and not become experts on sort of the stack of RAG, but rather on the app I want to build with RAG. So what's my data, and how do I build the application connected to this, and buying some solution that will help me run that process in parallel.
Marwan?
Yeah, I tend to agree that the main challenges go from going from POC to like production, and this happens on like different levels, from like preparing your data. So we've seen going from just text only to multimodal data, and the quality of the data and ensuring that the data doesn't have PII data means that even in your data preparation phase, you have to like combine model inference into your pipelines, and that means running on a heterogeneous cluster of compute and doing that in a very cost-efficient manner. So there's some benchmarks we've done by like indexing the entire Falcon data set that was used to train the Falcon LLMs. We did that with Pinecone, and we were able to achieve like 10 times cheaper costs on Ray. So you want like a system that like when you parallelize, you can sort of distribute the workload nicely. And then additionally, like on the performance side, like when you're deploying your LLMs, you also need to like have a good access to an inference engine that you can, very easily and quickly generate tokens.
Yeah, and you make a good point. The cost also is something that people don't think enough about. I think as you start like counting the tokens and how you pay all the vendors, it starts to add up pretty quickly.
Yeah, and at times, like at certain levels, like you might wonder if like maybe I'll do RAG sort of as batch inference on its own to generate, like certain things don't need to be like online running on like the most expensive GPUs. And so the more control you do have on your hardware, the more you can do with these trade-offs.
Yeah.
And I think this does also kind of tie in a little bit into fine-tuning, because we're talking about evaluations and agents, and each one of these is another LLM call with cost considerations and latency considerations. So this is kind of a use case, a strong use case for fine-tuned, local, quantized LLMs that you can run cheaply and inexpensively. Reminder, we do have a microphone there in the middle of the room in case people want to ask we'll have time for a couple of audience questions. Yeah. Okay, so maybe I should take one from the app here. I see a question here. Regarding optimized retrieval, how can I improve query construction to enhance document retrieval performance for legal or medicine? So I think that's definitely a fine-tuning kind of thing. There's also things about how can you improve the query construction itself. There's lots of little tricks with prompts, such as the needle and haystack. Studies done by Greg Comrant and Lance Martin from LangChain show distinctly you put your context last in the prompt. Seems like dark art magic foo, but there's all kinds of stuff with the prompt that you can do, such as few shots and chain of thoughts and reflection. Okay, let's take a first audience question.
Hi. You talked about latency and cost as trade-offs.
Right.
With RAG and hybrid RAG and so forth. What is your view on accuracy? Is there a point on accuracy here in terms of the cost and latency trading off?
Yeah, I guess it's like a triad of quality, latency, and cost, and under quality you could put in accuracy or any of the evaluation metrics that our folks here have spoken about. So I guess it's the answer, I hate to say, it depends on your specific use case, but you have to weigh these trade-offs, and I think maybe I would add one more, which is like security and safety and privacy and all these, like just all depends on your specific use case and what weighs more and what you're building.
I just want to add to that I think quality of results usually comes as number one. Like if it's below a certain threshold, nobody cares. It's just not a good app. But I think after you get to that level of baseline that you think this is kind of good enough, then I think latency and cost become something that you can, like Marwan said, you can optimize for and you can make better. And if you control all the pieces, you can certainly do a lot to improve that, yeah.
And are there any particular RAG models, like the hybrid RAG models that are, I mean, have you done any testing for accuracy?
So any RAG system, I think, should be tested for accuracy. Like you have to have a baseline on which you start, and then add these components on top of it. So you start with a vector-based RAG system, then you add these additional complexity features like graphs or agents and other things on top of that. So I would say that it's very subjective to the data set and what set of tools are being used, depending on the problem at hand.
Yeah.
Thank you.
In terms of evaluation, at Vectara you said that you switched from LLM as a judge to HHEM. How did that help and how did that switch improve the evaluations?
So HHEM is a model that detects hallucination. And so when you do, for example, faithfulness, I think it's the name of the metric where you judge whether the generated output is grounded in actual context. You can retrieve the right context and then it may actually hallucinate and create the wrong output anyway, or say something that's not in the context. You want it to be really accurate. So HHEM is a model that in some way measures faithfulness. We call it factual consistency. Okay. But the point is it's not using an LLM underneath. It's just a model that's been trained by us. It's open source. It's on Hugging Face. You can go look it up. And use it. We also, of course, have it in our platform for free. You get it, automatically when you query Vectara. You get that factual consistency. Sorry, I can't speak. Consistency score, and it's faster, cheaper, and more reliable because it doesn't depend on the intricacies of LLMs. How they're a little bit sometimes inconsistent. They can change their mind a little bit, and they can change, especially with models like you have. GPT-4, this version, and like the next version, you might find that in evaluations you get different results.
Any cons of switching
to
the HHEM, like instead of the
don't know. I mean, it doesn't. LLM as a judge is broader. It can do other stuff other than faithfulness. Maybe it's just more broadly used. We don't have the equivalent for other types of checks. That's what I would say.
And then I would say just make sure you keep in mind that there's benchmarks for the LLM models themselves. So there's the embedding model, which has its own benchmark leaderboard called MTEB, leaderboard run by Hugging Face. Watch out though, because the data is public, they learned the hard way that models are overfit to that leaderboard. So there's a blog by Hugging Face saying what to watch out for avoiding those overfit models. HHEM, there's a ton of different benchmarks for the generative LLM models themselves. LLM as a judge is more for how to evaluate your own RAG system, which is different from the benchmarks that are all out there and published and updated all the time. So your RAG system could perform differently, maybe even a small model works fine in your RAG system. And so that's what this LLM as a judge. The data quality is going to be super important in your evaluation golden data set here. So yeah, I'd pay attention to that.
Thank you.
I don't know, I think we got 1 minute left.
Yeah.
Maybe real quick, you mentioned ways to detect hallucinations, but Christy, I like your tip about adding the context at the end of the prompt. Like, are there other quick tips you could give us for enforcing, like, hey, use the context, don't hallucinate?
It's a really this is really tricky. Yeah, my own experience playing around, I feel like the data, if the data is not there, there's just nothing that's going to help it retrieve something that's not there other than probably adding something like an agent. I should be able to think off the top. I'll add stuff in the prompt if I can think of more tips. Thanks. All right. So yeah, thanks. Oh, do we have time for one? Okay.
We have one more. Yeah.
20 seconds.
All right. How do you think VectorDB will affect RAG? Is there any difference between all these open source VectorDB versus almost existing database? They all claim to have VectorDB. What do you think?
Oh, well, okay, I guess that's for me because I used to work for a vector database company. So I think depends on what you want, but scalability is one of their first things to look at. Look at their architecture diagram.